Okay, this video continues the lessons about solving equations. In this case, the x value is tangled in more than one operation, and so you're going to have to unwrap x and get it by itself by taking more than one step, and that's why I've referred to these as two-step equations. Here is a batch of them. This is, after all, supposed to be a refresher. So go ahead and try to solve for all of these variables. It's not always x, as you see, r here, for example, in this case. Go ahead and solve for all 10 variables and hit the pause button. And when you come back, I'm going to show you the answers to all 10. All right, I'm going to assume that you've done that, and here are those answers. And hit the pause button if you need to make sure that you've checked all of these answers. Remember, like I said in the last video, you have to get not only the numerical value, but also the sign right. This needs to be -4, and this needs to be +6, and so on. So, if you have all 10 right, then maybe you know this well enough to avoid the video, but I would recommend it for almost everyone. And certainly anyone who doesn't have all 10 right. Continuing with the keys that I talked about in the first video, the third key to solving linear equations, when x is tangled in more than one layer, and I'll show you what I mean by tangled in more than one layer when I get to an example on the next slide. When that happens, unwrap it in the opposite order of PEMDAS. So let me show you what I mean. I'm going to focus on just 5 of these 10 problems, the ones that are highlighted here. Let's start with that first one. Why do I say it's tangled in more than one layer? Well, x is not only being multiplied by 5, but it also has 8 added to it. So I've got to get rid of the 5 and the 8 in order to get x by itself. And I've got to get rid of those two numbers, 5 and 8, in the opposite order of PEMDAS. 5 is being multiplied, 8 is being added. Going in the opposite order of PEMDAS, I get rid of the addition first. And I get rid of it by using the opposite operation, subtraction. So I subtract 8 from both sides. Now I'm going to have on the left just 5x, and on the right I'm going to have 0. Now I get rid of the 5, which is being multiplied, by dividing it. I divide both sides by 5. I'm going to end up with x equals 0 over 5, which, after all, is the answer that I gave you, 0. How about the second one here? R is not only being divided by 4, but it also has -10 combined with it. I've got to get rid of both of those numbers in the opposite order of PEMDAS. The -10 I move by adding 10 to both sides. Now I'm going to have r over 4 equals, well, didn't mean to do that. -10 plus 10 is 0, so I'm going to have r over 4 equals 0. I move the 4 by multiplying both sides by 4. And I'm going to have r equals 4 times 0, which, after all, is 0, just like I told you the answer should be. Next one, I want to get k by itself, and there are two things happening to it. The first thing I'm going to move is that 1. I subtract it away from both sides. Now I've got -3k is equal to 36. 37 minus 1 is 36. Sorry about the handwriting here. It's not easy to use the tools that I have sometimes. -3k, I've got to get rid of that -3. I want k by itself. So I divide both sides by -3. 36 divided by -3, that's what I told you the answer should be. 36 divided by -3 is -12. The next one, number 4 here, you might be tempted to use the distributive property and distribute that -5 to both pieces inside the parentheses. You can if you want to, and that solution will work, but I'm going to show you a faster way. Remember, I want to undo in the opposite order of PEMDAS. PEMDAS says the first thing I deal with is anything inside parentheses. So that means this -5 that's being multiplied is a later step. If I unwrap in the opposite order of PEMDAS, then I want to unwrap that -5 first. If it's being multiplied, I divide -5 away. Divide both sides by -5, cancel the -5's on the left, and I'm left with 10 plus x is equal to 6. And now I just move the 10 by subtraction, and I'm going to be left with just 10 on the left. I'm sorry, just x on the left. And what's 6 minus 10? It's the answer I gave you, negative 4. If you need to, hit the pause button and study this one, because I do recommend that you think about this possibility. It definitely is faster than distributing the negative 5. If you distributed the negative 5 to solve this problem, that's not incorrect. That will get you to the right answer. It's just a longer way. Last one that I'm going to work out for you here. I want x by itself. It's got 7 being added, and the whole thing is being divided by 24. Now here's a challenge in remembering how to do the opposite order of PEMDAS. You need to remember that a dividing line is a grouping symbol. So x plus 7, it's like there are parentheses around the x plus 7. So I've got to save that plus 7 till the end. And this is where a lot of students make mistakes. I've got to move the 24 first. So I multiply both sides by 24. The ones on the right will cancel. I just have x plus 7 left, and on the left I have 24. Now all I have to do is subtract away that 7, and I'm going to have just x on the right, and on the left, 24 minus 7, that's the answer I gave you, 17. Okay, that's it for this video lesson. If you have this down, you're ready then for the quiz for 4B, and if you do well with that, you'll be ready for the video lesson for 4C.